video is an introduction to charge. Electricity is all around us. We use electricity to cook our food, to heat our homes, and it is thanks to electricity that you're able to watch this video. However much electricity is part of our everyday life, we cannot observe electricity directly because we are unable to see electrons with our bare eyes. However, we can observe the effects of electricity. We have already mentioned a couple of these effects. Here are a few more. When you rub your shoes on the carpet and afterwards you touch your cat, or in fact any other animal or person, you get a small shock. You can comb your hair and afterwards use the comb to pick up small pieces of paper. Finally, lightning during a storm is also a result of electricity. Here, the same thing happens as when you touch your cat, except at a much bigger scale. All of these examples are a result of an unbalanced distribution of positive and negative charge. To explore this further, let's recall the basic structure of an atom. Atoms have a positive nucleus that is composed of protons and neutrons, and this nucleus is orbited by electrons. A key point is that protons are positively charged while electrons are negatively charged. Neutrons, as their name suggests, are neutral. In other words, they have no charge. There are only two types of charges, positive and negative. Like charges repel and opposite charges attract. This means that if you have two positive or two negative charges, they will repel each other, while if you have a positive and a negative charge, they will attract. Another key point here is that protons are tightly bound in the nucleus, while electrons are free to move. This point is important when we start talking about charged objects or how charge moves. As we said, electrons are free to move. This means that when we discuss electricity, we always speak in terms of the movement of electrons. So for example, the electricity in your computer cable is a result of electrons moving from one place to another. When an object has a surplus of electrons, it is negatively charged, and when it has a shortage of electrons, it is positively charged. Let's see an example. Imagine that we have a conducting sphere. Conducting means that the sphere is made of a material that allows electrons to move around easily. Most metals are good conductors, while for example rubber or glass are bad conductors. Bad conductors are also called insulators. On our sphere, we have 4 positive charges and 4 negative charges or electrons. Since the number of positive and negative charges is the same, we say that this sphere is neutral. It is neither positively nor negatively charged. Now let's take a negatively charged rod, a rod that as you can see has a surplus of electrons, and observe what happens when we move this rod close to the sphere. Here is what we would see. Since the rod is negatively charged and like charges repel while opposite charges attract, the side of the sphere that is closest to the rod becomes positively charged, while the opposite side becomes negatively charged. Next, let's connect a cable to this sphere. Through this cable, electrons can freely travel down to the Earth. We say that the sphere is earthed. Earthing is used, for instance, in lightning rods on top of tall buildings. Since the positive charges on the sphere are attracted by the rod, while the negative charges are repelled, negatively charged electrons will travel along the cable down to Earth and will leave the sphere. As a result, we are left with a positively charged sphere, and when we remove the rod, this positive charge is distributed evenly. But what happened to the electrons? The sphere has lost these 4 electrons, however, at the same time, the Earth has gained these 4 electrons. A key concept here is that just as with energy, charge cannot be destroyed or created during interactions. This means that charge is conserved. This completes our introduction to charge. In the next video, we'll learn about Coulomb's law.